In this example, we're going to find the derivative of the function f of x equals the square root of 2x plus 1. Then we will use that result to find the slope of the line tangent to the graph at the point with x coordinate 4. So we start with the definition of derivative. F prime of x is the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay, well now let's look at our function. F of x is the square root of 2x plus 1. So f of x plus h is the square root of 2 times the quantity x plus h plus 1 minus f of x, which is just the square root of 2x plus 1 over h. Let's go ahead and do a little algebra here. We can rewrite the 2 times the quantity x plus h as 2x plus 2h. This limit has the form 0 over 0, which we know to be indeterminate. So we're going to have to do some work here. We saw in the previous chapter dealing with limits, situations where we had limits with indeterminate form 0 over 0 involving a sum or difference of radicals. And one of the things that we did in cases such as that is we used the conjugate, and that's what I'm going to do here. So I'm going to take what I have and I'm going to multiply by the conjugate of the numerator divided by itself. Remember, the way you get the conjugate is you change the middle sign. Now what happens is, when I multiply the numerators together, if you look very carefully, the form, let me pull this down, of the two numerators, in the first case I could write a minus b, and then in the second case I would write a plus b. That's the sort of general form of the two numerators, a minus b times a plus b. Well, we know that when we multiply those together, we get the difference of squares. We get a squared minus b squared. And what does that look like in this specific case? Well, a is the square root of 2x plus 2h plus 1. When I square that, I get what's underneath the radical. And then I have minus b squared. B is the square root of 2x plus 1. When I square that, I get what's underneath the radical. And I'm going to leave the denominator alone. So now I'm going to remove the parentheses here. It gives me this. Again, leave the denominator alone. Notice the cancellations in the numerator. We've got cancellation here, and we've got cancellation here. So what we're left with is the limit as h approaches 0 of 2h over h times the sum of these two radicals. Well, hopefully you can see, or do see, that that's going to allow us to simplify further, canceling those common factors of h, one on the top, one on the bottom. It's supposed to be an h. Well, now we're ready to actually take the limit. So as h approaches 0, what do we get? Well, we get 2 divided by the only h that appears in this expression is this one here. That's going to 0. So in the denominator, we have the square root of 2x plus 1 plus itself. That is 2 over 2 times the square root of 2x plus 1. 2's cancel. And there's the derivative. The next thing we want to do, if you recall, is to find the slope of the line tangent to the graph of f at the point with x coordinate 4. So let's do that. So what we're looking for is f prime of 4, the derivative of f at 4. That's our slope. We take our derivative function. We replace x by 4, simplify, and we see that the slope is 1/3.